Which chloroderivative of benzene among the following would undergo hydrolysis most readily with aqueous sodium hydroxide to furnish the corresponding hydroxyl derivative? Chloroderivative of benzene, meaning chlorobenzene. Okay, if you are observing, this is also chlorobenzene, this is also chlorobenzene, all are chlorobenzene. This is what is meant by chloroderivative of benzene. Undergoes hydrolysis most readily. Hydrolysis means this chloride is going and OH minus is taking its place. This is more clear in the next part of the question with aqueous sodium hydroxide. Aqueous sodium hydroxide will give OH minus ion. So, now we need to analyze which type of reaction is this. This is a substitution reaction. Cl minus is going its place and in its place OH minus is going. It's also a nucleophilic substitution where Cl minus, a nucleophile, is substituted by OH minus. If a nucleophile is attacking the species, this species should not be electron rich. It should be opposite. That is, it should be electron deficient. Opposite. If an electrophile is attacking, this should be electron rich. As a nucleophile is attacking, this system should be electron deficient. Then the reaction will occur readily, fast. So considering those things here, we know that nitro group is an electron withdrawing group. And in this benzene, we have 3 nitro groups. So it's highly electron withdrawing. If there are electron withdrawing group, they withdraw electrons. And therefore, the density on benzene decreases. A nucleophile will therefore attack this carbon easily. Comparing it to option B, we have one NO2 group, one electron withdrawing group. The effect of electron withdrawing is less here. Comparing to our option C, we have an electron releasing group. Due to plus M effect, Me2 acts as an electron releasing group. Therefore, this compound is reluctant to undergo this type of reaction. Last comes this compound chlorobenzene, which does not have either electron withdrawing group or releasing group. There are 3 electron withdrawing group in our first compound, only 1 in our second compound. There is electron releasing group in our third compound. There is no such thing in our fourth compound. So it's very clear that option A reacts fastest, followed by option B, followed by option D, followed by option C. So the overall order is like this: A greater than B, greater than D, greater than C. And here our answer, as they asked most readily, our answer is option